Hello, this video is going to go over Chapter 25, Objective 3, Urine Production. And I'm going to break this up into 3 different videos, actually. This one's a pretty long objective, so I'm going to go, this is going to be 3A, I'm going to go 3B, and then 3C. So this one is going to be over urine formation. So there is a short little video for you to watch if you need a little bit more visual on how this process works. It's a really good little video, but it just kind of gives you an overview of what's happening. So urine formation, and these are how I'm going to break this chapter objective up. I'm going to go for filtration, then the next one's going to be tubular reabsorption, and then the next one's going to be tubular secretion. So for urine formation, you need to know these 3 major processes. You need to know the order that they occur in, and you need to know just generally what's happening. And then we'll get into the specifics. But filtration, when we're talking about filtration, that's the first event that's going to happen with urine formation. Now, filtration is non-specific, so what that means is everything and anything is going to be filtered out of the glomerulus based on particle size. It has nothing to do with, oh, does the body want to keep this, or is the body trying to get rid of it? We're not in that position yet. We're just getting everything out of the capillary there, the glomerulus, based on size. And what determines the volume of filtrate that's going to be formed is blood pressure. So the higher the blood pressure, the more filtrate you're going to produce. The lower the blood pressure, the less filtrate you're going to produce, which again is going to then in turn affect urine production. So if you have a high blood pressure, you're going to get more filtrate, ultimately more urine production. Low blood pressure, not very much filtrate, less urine production. So it does tie all in together. Tubular reabsorption involves the nephron returning water and some of the filtered molecules back to the blood. So some of the filtrate that showed up in this first step right here, remember it was not specific, it was separated by size. You know, some of that stuff we actually want in the blood, like sugar. We don't necessarily want that going out in the urine. We want to put that back in the bloodstream so the body has access to that to do its daily tasks. So not everything that gets filtered actually goes into the urine. So the tubular reabsorption is the way we return it back to the blood, especially that water. And then the last one, tubular secretion, this is the nephron cells transport solutes from the blood back to the filtrate. So while we have this major filtration going on right here in this initial step, there is some back and forth movement of materials as things move through the nephron. So that is called tubular reabsorption, when you take things from the nephron, put it back in the bloodstream, and then tubular secretion, when you take it from the bloodstream and put it back into that nephron. So again, just some definitions here for you guys to make sure you know. Filtration is the mass movement of water and solutes from plasma to the renal tubule that occurs in the renal corpuscle. Again, you're going to get a lot of these terms in lab. So if these terms aren't making sense yet, as far as renal corpuscle and renal tubule, you're gonna get that in lab. But let me just kind of break this down just a little bit. So filtration is the mass movement. We're moving large amounts of particles and fluid from the plasma into the filtering part of the kidney. That's called the nephron, and the filtering part of the nephron of the kidney is called the glomerulus, which is located within the renal corpuscle. So and I'll show you a picture of that in a minute. Reabsorption is the movement of water and solutes from the tubule, from the nephron, which is a tube, back into the plasma. It is regulated, so you've got some hormone control regulating what goes back into the blood. So we'll talk more about that as we move through. So yes, I know you're surprised to hear, but yes, hormones are regulating what's being filtered and how the urine formation is being done. So yes, there's a hormone involvement. Secretion, the movement of substances from the blood into the tubular fluid. So you're taking things from the blood, putting it back into the nephron. Secretion is essentially the opposite of reabsorption. So again, reabsorption is kidney to blood. Secretion is blood to kidney. Okay, yeah, we've got some fancy words there, but that's just the general overview. Excretion is what goes into the urine, and the is the end result of these above 3 processes. So excretion is actually urine at that point. It's the end of the urine production. We've made the urine, now we're fixing to get rid of it. So let's talk a little bit about the first part, filtration. So what you're seeing here, you've got your afferent arterial. Now keep in mind your afferent arterial, afferent means you're bringing something towards. So in this case, you're bringing something towards the renal corpuscle. And then efferent arterial means you're taking something away. In this case, you're taking something away from the renal corpuscle. Now this capillary bed right in here, it's kind of faded, but you can see it. That's the glomerulus, okay? This is where filtration is occurring. I want you to notice this is oxygenated blood. These are both arteries. So we're not having a gas exchange going on here. We're just having a particle filtration happening. And remember, this is based on particle size, by the way, remembering from our previous slide. So the glomerulus is all of this capillary network in here. And capillaries are very porous. These are very porous capillaries as far as capillaries go. Remember, there's a degree of porosity on those capillaries. And the glomerulus sits inside of this Bowman's capsule right here. And the whole thing is the renal corpuscle. Now, the filtrate, which is going to be pushed based on blood pressure, see these red arrows, that's showing you that these particles are being forced out of the capillary into Bowman's capsule, and this is now called filtrate. And then you can see number 2 right here, look at the green arrow. This is where you have materials going from the kidney into the blood, okay, that's reabsorption. And then secretion, you can see the arrow direction. You can see that it is going from the blood into the kidney. And then excretion is urine leaving the body, okay? So just an overview of all of that. Our focus in this one is going to be right up here in this part right here, filtration, where we're actually getting the particles leaving from the glomerulus into Bowman's capsule. So you've got mass movement of water and solutes from the plasma to the renal tubule that occurs in the renal corpuscle. So all of this right here is that renal corpuscle. It includes the glomerulus and Bowman's capsule. You've got your blood coming in, and again, this is going to be under a certain type of pressure, right? Blood pressure. And it's going to enter into the glomerulus, and it will leave by way of blood pressure based on the pressure and particle size. You're going to get about 180 liters a day of filtrate produced. That's a lot. But look at how much urine you're going to produce. 2 liters. So you've got a lot of filtrate that is being produced, but only 2 liters of urine. So if we go back a slide, at 1 right here, this is your filtration. 180 liters are being filtered from the glomerulus into Bowman's capsule. But when you get down here, you're only getting 2 liters that are actually exiting the body. So what's happening with that 178 liters? Where did it go? Well, it's going to get resorbed, okay? That's where it's going to go. So 99% of that 180, 99% of it gets reabsorbed back into the blood, and only about 1% of it actually exits the body in the form of urine. That's pretty amazing. So a few more definitions that you need to know. Renal fraction, this is the portion of cardiac output that flows through the kidneys. So remember what cardiac output is. This is what is leaving that, we're going to really be talking about the left side of the heart here. That's what's going to be leaving that aorta. And of the 100% of the blood volume that's leaving the aorta, 21% is going to go to the kidneys. So that's a pretty big percentage actually. Renal blood flow rate is the rate of blood flow through the kidney, which is the renal fraction times cardiac output. That is actually how you calculate renal blood flow rate. And you're looking at about 1,176 milliliters per minute. That's average. Now, the renal plasma flow rate is the renal blood flow rate times 55%, because if you remember, plasma is 55% of the whole blood. So you're looking at the plasma flow rate rather than the entire blood flow rate, okay? So the plasma flow rate is the percent of plasma in the blood, which is going to be about 650 milliliters per minute of plasma that's going to be flowing. So this just gives you another little visual here. You've got 100% of this blood coming from the afferent arterial entering into the glomerulus, and 20% of that is going to go out in the form of filtrate, 80% is going to stay in the efferent arteriole. This is your filtration fraction. So the percentage of blood that is filtered by the glomerulus is about 20%. So you're looking at about 123.5 milliliters per minute. That's pretty large. And then if you look, of the 20% of the volume that actually enters into Bowman's capsule and into the nephron, about 19% of it goes back into the blood. So again, about 1% of what got filtered actually goes into the form of urine. Glomerular filtration rate. You're going to see this if you have any kidney studies done or anything like that, this little number will pop up. Glomerular filtration rate, GFR, it's the amount of filtrate produced each minute. You usually get about 125 milliliters of filtrate produced each minute. So just know that number. You got your filtration fraction right up here. So that's really about all we're going to worry about. And then your urine flow rate, you're going to create about 1 milliliter of urine per minute. Filtration pressure, like we said, pressure makes a big difference on the volume of urine that's going to be produced. So the formation of the filtrate is due to the pressure gradient in the renal corpuscle. So again, you've got your afferent arteriole, efferent arteriole, you have your glomerulus, you have your Bowman's capsule, and you have that first section of the nephron. This is that renal corpuscle right here. Formation of the filtrate, again, is filtration pressure, so it's dependent on 3 different pressures. So this, not to be a little confusing, but the words on these are kind of tough. So you've got glomerular capillary pressure, GCP, also known as the glomerular blood hydrostatic pressure. This is the outward pressure of blood pressing on capillary walls. So bottom line, what we're talking about here is basically blood pressure, okay? It's the outward pressure of the blood, so it's your blood pressure. But they're calling it glomerular capillary pressure. It's the pressure within the capillary of the glomerulus is what it is. And it's running about 50 millimeters of mercury. Now, your capsular hydrostatic pressure. Hydrostatic has to do with water. So it's the inward pressure from the filtrate accumulating in Bowman's capsule. So think about it this way. You're trying to push something outward, but you've already got a lot of liquid in that Bowman's capsule, but yet you're still trying to push fluid in to Bowman's capsule, but there's already liquid there. So that is the pressure pushing back, preventing you from being able to push things out because you've already got a lot of pressure in that Bowman's capsule already. You've already got fluid. And it's about 10 millimeters of mercury. So as long as your capillary pressure, as long as your blood pressure is higher than this, then the fluid will move in the right direction, okay? And you'll get urine creation. Now, you also have another opposing force to blood pressure. You have 2 opposing forces right here to your blood pressure. And that inward pressure is called blood colloidal osmotic pressure. This has to do with the plasma proteins. So capsular hydrostatic pressure is the pressure of the fluid, and then your blood colloidal osmotic pressure has to do with the solute particles. So it's due to the osmotic force of the plasma proteins within the glomerular capillaries. Because remember, not only are we pushing fluid out of the capillary, we're also pushing particles out of the capillary based on size. And those particles, if you've got stuff in the way, it's going to be hard to keep pushing stuff into that area if you've already got stuff there. So just kind of a crude understanding of how that works. But bottom line is, if your outward pressure is greater than the sum of your inward pressures, you're going to create urine. And it is. That's how it's supposed to be. When your inward pressures exceed your blood pressure, like maybe a person has low blood pressure, that's why they can't make urine, because they can't overcome those pressures in the opposite direction. So your formula for filtration pressure is your glomerular capillary pressure minus your capsular hydrostatic pressure minus your blood colloidal osmotic pressure. So when you set all the numbers up and you put the numbers in, you can see it a little bit better. So if your overall pressure, blood pressure coming in is 50 minus your inward pressure of 10 minus the other inward pressure of 30, that's going to leave you a net 10 millimeters of mercury of pressure pushing outward. And that's what you want. You want that to be a positive number, so that way urine is created. This just shows you the big picture. So if you haven't learned this in lab yet, in this one you have your afferent arteriole, blood going into this capillary network called the glomerulus. And then you have that oxygenated blood leaving, which doesn't, you've already filtered 20% of that into the Bowman's capsule. So this area right here, this capsular space, this is Bowman's capsule right here. And this is the entire capsule, corpuscle, sorry. Okay, and then all of that filtrate that is being pushed out of the glomerulus is that net filtration pressure, and it's going to enter into this first section of the nephron called the proximal convoluted tubule. So you have got your pressures pushing inward on the glomerulus, your blood colloidal osmotic pressure, and then you've got your capsular hydrostatic pressure, both pushing inward on that glomerulus. So as long as the blood pressure in the glomerulus exceeds the sum of these two, you're going to create urine. Outward pressure, inward pressure, inward pressure. Okay, so that just kind of summarizes those three pressures that we talked about a second ago. Again, just another picture, showing you what's going on. So you've got that glomerular capillary pressure pushing outward. That arrow should be bigger because that pressure should be greater than the sum of these two inward pressures. And that's going to conclude part 1. And we will pick up on part 2, I'll call it 3B, here in just a second.